Hey guys, welcome back. So we're going to do another day on word problems with inequalities. Let's go and write down today's objective. Today's objective is I can solve and graph inequality word problems. All right, now this first question is something that you've seen, not exactly, but you've seen something like it yesterday. So I'm going to have you guys do this one on your own. So for this first one, we have the scenario is that a senior citizen is 65 years old. Right? I want you to do both A and B. Right? In A, you have to come up with an inequality that shows someone who is a senior citizen, and in B, you have to show me the inequality of someone who is not a senior citizen, and you're going to go ahead and graph them as well. So go ahead and do that right now. All right, guys, so now for part A, someone who is a senior citizen, we know that we're going to be comparing X to the number 65 because someone who is 65 is a senior citizen. We are going to put an or equal to bar here because 65, if you are 65, you are a senior citizen. Now some numbers that you can put in here for someone who is also a senior citizen would be like 70, 88, 92. These are also people who are senior citizens. Now if I were to put one of these numbers in here, that would tell me that, for example, 70 is greater than 65, so therefore I'm going to put a greater than symbol. So a senior citizen would be greater or equal to 65. Okay? Now to graph this, we're going to go ahead and put 65 on the number line. We are going to put a closed circle because if you are 65, you are a senior citizen. All right, and then again, we're going to check this. So for something to fit in here, what number could I put in here? Well, 100 works. 100 is greater or equal to 65. 100 is on this side of the number line, so we're going to shade this side of the number line. Okay? All right, for B, this is saying someone who is not a senior citizen, so X compared to 65. Now, there is not going to be an or equal to bar this time because if you're 65, you are a senior citizen. We want to find out who's not a senior citizen. So some numbers of people who are not senior citizens, well, you guys aren't, so 14 and 13-year-olds are not senior citizens. Mr. Haddad isn't, so 31 is not a senior citizen. If you put these numbers in for X, then this is going to be less than 65, okay? Again, there is no or equal to bar, so when we plotted this at 65, we have an open circle, and then we're going to shade a number that we can put in here would be like negative 100. So negative 100 is less than 65, and negative 100 is on this side of the number line. Okay, so that's the graph for that one. Okay, hopefully you got that those correct. They are kind of review. So let's just go ahead and take a look at the new stuff. Now, number 2. Okay, for number 2, I'm going to read this problem for you, and then we're going to go ahead and tackle this. So it says, you have $15 to spend. You are going to the arcade with your friend today. The arcade charges a $3 admission, and each arcade game is 75 cents. Now for this first part, what they want us to do is they want us to write an inequality. We are going to solve it and graph it, but for right now, we're dealing with the writing part. So we're going to write an inequality that would represent the situation. Right? Now, we know that each game is going to cost 75 cents. Now over here it says, let X represent the number of games. Okay, so when you know how many games you play, you're going to actually multiply it with the 75 cents. So I'm going to go ahead and put 0.75, and I'm going to put the X next to it, because once I know what the games are, I'm going to multiply it by 75 cents. Now, just for, say that you and your friend went into the arcade. If your friend didn't play at all, your friend would still have to pay money though. Your friend would have to pay $3 because that's the admission fee. Same thing with you. You are going to have to pay $3 just for walking in the door. Now say that you played 0 games. If there was a 0 here, then you'd only pay $3. But then if you start playing some games, then that's going to add up to the amount of money you're going to spend. Now all this is going to be compared to the number 15. The reason is because 15 is the amount of money that you have. Okay? We need to put an inequality in here. The reason is because we want to find out any number of games you can play. So how are we going to do this? Well, on this side, I know this is the money that I'm going to spend. So I'm going to write the word spend above it. Over here, this is the money that I have, or that you have. Okay, now the question is, do you want to spend more money than you have, or do you want to spend less money than you have? The answer is that you want to spend less money that you have, right? The other part of this is that, is it okay if we spend exactly $15? The answer is yes, we are able to do that. So I'm going to put the or equal to bar here because we can spend less than or equal to what we have. Okay? Now what we're going to do is the second part, which is solve it. Now this is a two-step inequality, so we're going to get rid of who's furthest away. So we have 0.75 plus, x plus 3 is less than or equal to 15. The first thing I'm going to do is subtract 3 from both sides. That'll cancel out the 3's over here. 0.75x is now less than or equal to, that's 12, okay? What we need to do now is divide both sides by 0.75, right? The 0.75 will cancel, and x will be less than or equal to 16. Okay, now this right here answers the solving part. Alright? Now, the next part of this is that you have to graph it. And we already have experience doing that. We're going to go ahead and put the 16 there with a closed circle because it's okay to play 16 games. And then we're going to go ahead and put in a test point to find out what type to shade. So something has to be less than or equal to 16. We can put negative 100 in there. Negative 100 is on this side, so we're going to shade this side. Now, you are going to need to know what this actually means. Now, this graph is telling you something very specific. Now, 16 represents x. X represents the number of games. So, what you're going to need to write down here is that you can play 16 games, right, or less. You can also play less. So is it okay for you to play 15 games? Yeah, 15 is in the shaded region, right? Is it okay for you to play only 1 game? Yeah, 1 is in the shaded region. Is it okay for you to play 20 games? The answer would be no, because you don't have enough money, all right, and you would be in the non-shaded region. All right, guys, so we're going to start number 3 together. All right, let me go ahead and read this for you. So it says a taxi cab charges $2 for the flat rate, just to sit in the taxi cab, and then an additional 50 cents per mile. Bill has no more than $20 to spend on a ride. Write an inequality that describes the situation. You need to solve it and graph it. So we're going to do the writing part together. So we're going to write this inequality that describes the situation. You guys are going to solve it, and you guys are also going to graph it. Okay? So let's go ahead and do that. So now, for this one, it says, again, it says that it's 50 cents per mile, right? And it says let x represent the number of miles. So once you know the number of miles, you're going to go ahead and multiply that with 0.50, because that's the amount of money that you're going to be spending on just the miles. But again, like I said, he charges a $2 flat rate, and because of that, that means just for sitting in the cab, even if he doesn't drive anywhere, you have to pay $2. Okay? Now we are going to be comparing this to 20. So we're going to be comparing it to 20. Now again, 20 is the money that he has. Right? And then all this right here is the money that he's going to spend. Okay? Now, it's okay for him to spend exactly 20. So this is going to be an or equal to bar. Now, we're going to figure out, does he want to spend more than he has, or does he want to spend less than he has? He wants to spend less than he has. Okay? So, the next part of this, now this represents 50 cents per mile plus the initial fee for sitting down in the cab. We want it to be less than or equal to 20. Now what I want you to do is solve it. So go ahead and solve 50x plus 2 is less than or equal to 20. And then I want you to graph it. Go ahead and do that right now. Okay, so to solve this, we first have to subtract 2 from both sides. The 2's will cancel. All right, we get 0.50x is less than or equal to 18. Then we're going to divide both sides by 0.50. Alright, these cancel, and you wind up with x is less than or equal to 36. Okay? Now, to put this on the graph, we're going to put 36 with a closed circle. And then we are going to put 36 there. And then the number that we're working here would be like negative 100. Negative 100 is less than or equal to 36. That's true, and negative 100 is this way. Okay? Alright guys, so down here it says, what does the graph represent in the content of this problem, of problem number 3? Now, again, x represents the number of miles, and that means that all this right here is x. So again, if the destination was 30 miles away, it's a solution. You can do it. If it was 10 miles away, it would work. But now if it was 50 miles away, it would not be in the shaded region, and it would not be a solution. It's not a possibility for this cat ride. Okay? So what we're going to write is that the miles driven must be 36 miles or less. Okay? Alright, now, for this next problem, number 4, alright, I want you guys to do this one on your own completely. So you're going to start out by writing the inequality, solving it, and graphing it. So for this problem, it says you have $27 to spend on pizza. It costs $15 plus $2 for each additional topping. Okay, go ahead and set it up, graph it, and solve it, and then we'll pick up. Alright guys, so for this problem right here, again, it's $2 per topping. We're going to let x represent the number of toppings. So once you know how many toppings, you're going to multiply that with x. So there's my 2x. Alright? Now, what's the topping without pizza? Like, are you going to get toppings and not get the pizza? That doesn't make sense. So just to get the pizza itself is $15. So you have to pay the $15, then you're going to add the amount of money to the toppings. Now, we're comparing this to 27 because 27 is the amount of money that you have. Okay? This is the money that's going to be spent on the pizza. So you want it to be less than or equal to what you have. Okay? So now what we're going to do is we're going to solve this by subtracting. Let me write this over here. 2x plus 15 is less than or equal to 27. We're going to subtract 15 from both sides. You're going to get 2x is less than or equal to 12. Then we're going to divide both sides by 2. X is less than or equal to 6. Okay? So we're going to put the 6 on there. This is going to be a closed circle. And then we're going to shade this way because negative 100 is less than or equal to 6. Alright, now, what does this mean? Again, this means that you can get a pizza with 6 toppings or less. Okay? Alright guys, I'll see you tomorrow.